Well, hello there, ladies and gentlemen. Welcome, welcome, welcome. Hey, we're going to do a two-part, very exciting video on graphing trigonometric functions, but it's not just the basic good old sine of x and cosine of x. No. It's going to be something a little different. We're going to be talking about graphing y equals the sine of 2x or y equals 2 times the sine of x. So by the time you're done with both parts, you should be able to understand which of these graphs, the red, the black, or the blue, would match which of these functions. You should be able to be given a graph like this and write a function that matches it. You should be able to given a function like this and make a good graph. And you should be able to do with both of the, we should be able to do all that with both sine and cosine, right? And so at the end, what we're going to be doing is we're going to be graphing this function right here. F of x equals 1/2 times the sine of 4x, but it could be sine or cosine. So here in the first video, it's going to be more of the nuts and bolts, the how-to, right? And in the second video, we're going to talk about the why. We're going to tie it into the unit circle and discuss some of those background issues that can make this a little confusing, but that are super important towards understanding what's next and being proficient and having good retention. So in the future, you don't forget this, you don't have to relearn it, right? So here's the takeaway. Here's the mechanical part of it, right? You see this B right here? What it does is it changes the input by multiplication, right? And A changes the output by multiplication. So they're both integers, yeah? And what ends up happening, what you're going to see is that B changes the period. So for sine and cosine, the normal period is 360. So if you have a value of B, like this one says 4, well, that means if you had f of x equals the sine of 4x, well, the period, instead of being 360, would be 90. So using what you know about the features of the graphs of sine and cosine, you can adjust the period to make the graph. Now, what A doesn't change the period or even where the graph starts. All it does, it changes the amplitude. So the normal amplitude for sine and cosine is 1. So if you have a number for A, you just multiply that by 1, and that's your amplitude. So that's how you can find your minimum and maximum locations within one period of the function for either sine or cosine. So that's what we're going to do. Let's get into it right here, right? So we're going to skip all of the y, and we're going to just go to the end, and we're going to hit an example. So let's put it all together. So here's the deal, right? When you're graphing f of x equals a times the sine of bx, you really have to be careful of how the order of operations is really working right here. X is the input. It's an angle for this trigonometric function. What the b is doing is it's multiplying. And so you have to multiply that input by b before you can do anything with a. So you multiply b times the input, evaluate the function, whatever the output of the function is, you then multiply that by a. So, as we just said, b changes the input, a changes the output. The input is the x-axis, and so what ends up happening is it changes how wide or how long a period is on the x-axis or how short it is. That's what b does. And a changes how far up or down that the graph goes. So the end result is this, right? Here's the takeaway, and then we'll apply this takeaway to an example. Now, b changes the period, right? So your normal period for sine and cosine is 360. So you just divide by b, that's your period. And, right, a changes the amplitude. So whatever your amplitude is, you multiply that by 1 for sine and cosine. Boom, you're done. So let's jump into an example here, shall we? So let's say we're going to graph f of x equals 1/2 times the sine of 4x, right? Well, the way I would prefer to do this, the way I think is a great idea, is you just start with your basic function of sine of x, right? So sine of x starts at 0, 0, and it ends at 360, right? Comma 0. And halfway is your third x-intercept. Sine has 3 x-intercepts. One at the beginning of the period, one at the end of the period, and one at the halfway point. Half of 360 is 180. But let's say that your period was not 180 degrees. Let's say it was, say, 80 degrees or 180 degrees. Well, then halfway point would be 90, so you'd have an x-intercept at 90, right? Now, your maximum happens at a quarter of the way, which is at 90 degrees, and your minimum happens 3/4 of the way. 3/4 of 360 is 270. So just to summarize, here's how you can start with sine. The period's 360. It starts at the origin. So it goes 0 to 360. You have 3 x-intercepts at the beginning, at the end, and at the middle. You have a maximum at the 1/4 mark, and that's your amplitude. You have a minimum at the 3/4 mark. That's also your amplitude, but it's in the other direction, right? And so you can place a couple other known values so that you can make your graph. And here is, I don't know, here's a pretty rough sketch, but you get the general idea, right? All right, now, dealing with this, right, we can adapt what we know about sine, and sometimes sketching sine will just help keep in our forefront of our mind those key features, right? So now, those key features, the two that are going to change from here is the period's going to change and the amplitude's going to change. Let's start off with seeing how the period's going to be. Now, we know that the period is 360 for regular sine, so 360 divided by b will be our new period, so b is 4. 360 divided by 4 is 90 degrees. So we're going to be starting at 0, 0, and one period is going to end at 90. That's pretty quick. That means that halfway at 45 degrees, we're going to have a third x-intercept. So it's going to be right there at 45 degrees. Do you see? Now, we have a maximum at the 1/4 mark, which is halfway between this first half. So we're going to have a maximum over here, and we're going to have a minimum at the 3/4 mark. So the second, the halfway of the second half, right? Now, the normal amplitude for sine cosine is 1. So we multiply that by our value for a, which is 1/2. And our new amplitude for this function is 1/2. So instead of going all the way up to 1, here at this mark, we're going to go up to 1/2. So it's going to be right over here somewhere. And our minimum, halfway, if this is 1, this is 1/2, so it's going to be right over here somewhere. Do you see? So that's our major points for sine. So it's going to be 1/2 sine of 4x. We can go ahead and plug in a couple of other known values, and we can go ahead and make our curve. Do you see? So it's going to turn out that 4 of these periods are going to fit within one period of normal sine of x, and that's because of this 4 right here. So we can continue that. There's 2, and so on. All right, so that's a quick example. That's the takeaway. That's how you can apply these properties. So b changes the period. 360 divided by whatever b is will be your new period. You start with the key features of sine and cosine, and then your amplitude helps you find where that maximum is or that minimum is, and boom, you are done. So there is part 2 where we talk about why b changes the period and why a changes the amplitude. If you're interested in that, I'll leave a link in the description. You can check that out. There's some tie-ins with the unit circle. It's fantastic. If you're ready to move on, though, and you want to try some practice problems, learn about some other stuff in trigonometry, I would highly suggest using my website, thebeardedmathman.com. There's tons of stuff there. I'll leave a link in the description below. And if this has been helpful and you haven't enjoyed it and you've learned from it, give it a thumbs up. Share it on social media. And leave me a message. Tell me how things are going. I'd love to hear from you guys. Hey, until next time, hope you have a great day. I'll talk to you later.